Hello, this is Ray Marquis, Senior Application Engineer with Valen Corporation. This video is going to give an introduction and overview of structured data types that are used in Omron's N-series PLCs with Sysmac Studio. Why would one want to use structured data types in their program, or more specifically, we call them user-defined structures? But the first reason is that they can save time, and I'll show that in a quick video shortly after I go over this overview. They help you organize the programs and variables better. Once again, that'll be shown in the video. And then they make the program more readable. So what is a structured data type? It's a data type that's made up of a collection of other data types, or we call them members. There's one name assigned to that sort of collection of other members. And each member has its own data type, and it's attached to the data type when you're programming by a dot. So you might see a variable that looks servo.command.servo_on, as in the example here. Many structured data types exist already in the PLC when you first start programming. If you add certain hardware, it creates a variable of a structured data type. If you create a motion axis, for instance, it creates _MC_ax, and then 0 for axis 0, 1 for axis 1, and so on. And that is a variable of the axis reference data type, which is a structure. With the N-series PLCs, any system data structures will be named starting with an S, or _S more specifically. It's not a terrible practice for users to name their structures starting with _S as well. Structured data type members can also be other structures. So if we go back up to our example of servo.command.servo_on, that's an example of where one of the members happened to be a structure inside of the structure. So servo.command, the command is actually a structure name, .servo_on. So servo_on was a member in the CMD structure, and CMD structure was a member in the servo structure. So it sounds a little confusing, but I'm going to go through a use case here really quickly, and hopefully it'll make sense. A really good use case for structured data type variables is when you're doing motion. On the page here, I've just created some random motion function blocks. And rather than watch me go through and type everything in, I wanted to just show the difference between the normal way that people do it and using structured data type variables. You can see up here I've got a servo_on function block, or an MC power function block, and I created a variable to enable the servo called horizontal servo_on. Let's just create a new variable, or a new rung. I'll put in vertical. And then I'll add a function block for MC power. And then the vertical axis. Okay. So now I've got two servo_ons, and I have two move function blocks, but conceivably I could have many more axes, like in my program, and for each axis I could have many function blocks, move absolutes, phasing, gearing, all kinds of stuff that goes along with that. And so one of the ways that you can start to use structured data types very quickly, you can see here that I've got to put in a variable for position, velocity, acceleration, deceleration, and then I've got to go down here and I've got to do the same thing. But what I can do is make a structured data type that lets me create one variable name, and then it'll have the members will all be variables that I need for the operation of this function block, so that every time I create a motion function block, all I have to do is create one variable. I know it sounds confusing, but I'm going to show you how to do it, and then it should become clear once you play around with it. If you go into the data types, under data, it'll bring up this window, and the first thing you want to do is click on the Structures tab on the left here. There's Structure, Union, and Enumeration. And I've already created this one, and we'll use this motion FB structure that I created in a second, but I'm going to show you how to create one from scratch. Go in here, right click on it, and then select Create New Data Type. And I'll just call this RM motion FB junk, like that. And you'll notice it's pink, which means that there's a problem with it. This pink background means that the compiler doesn't like what I've done, because I can't create a structure without members. The next thing is to create a new member. I could go in here and say, this is my execute. I'll create another member. Let's see, what do we need? We go back here and I've got the position. So I'll go back to my motion function block. I'll click above the execute there. I want to click on the structure itself, not on one of the members. And then create a new member and call that position. And I know from memory that the position is LReal data type. So I'll change the data type of this to LReal. And I would continue doing that to create all of the different members of my structure that I want to use. I've created one above here already that has several members in it. You can see I've got execute, position, velocity, accel, decel, jerk, direction, and buffer mode. We'll talk about these last two, direction and buffer mode, in a minute. But now, how do I use this in my program? I'll just go over here to the program again. What I want to do is go to the global variables. I'll create a new variable called, let's call it vertical, and sorry if my spelling's off, vertical FB bits, just for fun. And then in here, the data type I want to select is, if I start typing, see my data type comes up now. It starts with M, motion FB data type. So I'll select that as my data type for this one, and then I'll create another one called horizontal. And it just automatically put in that it was the motion function block data type, because that's what was up here. It just kept the same one. Now, if I go back to my program, I can go here, and in this position, I can type in V for vertical, and then I get vertical function block bits dot P for position. And now I've got a position variable that I can use in my program that will associate with this function block. Same thing for velocity. I go vertical, and this I'm typing using the IntelliSense. So vertical FB bits, I highlight it, enter, dot, V for velocity, enter. So I just did that with about 4 keystrokes now. So it takes a little time to set up the function, the structure, but when you go to use it, it's faster. Vertical dot acceleration. You can see how fast it is to type this stuff in once you get it created this way. Very few keystrokes. I'm not typing out a lot of stuff. I do all the work at once. If I only had this one function block, the structure, and maybe it's a little more work. But now let's go back up here, and I've got this one. I can go through and do the same thing here and say horizontal dot position, and so on, to continue creating the variables for this one. The other thing that's handy is if we look up here, I've got this MC power, and there's a horizontal servo on bit that I created. But what I can do is go back to my data types and then create a new member, and I'll call this one servo on and make it a bool. which it is right there. If I go back to my program, then I can go here, and even though I didn't change anything else except for that structure, that's kind of like the map now of my variables for that that use that structure data type. So I can go horizontal function block bits dot servo on, vert function block bits dot servo on. So that's a quick use case overview of user-defined structured data types. When we created the structure data type right here, I said that we would talk about this direction and buffer mode. These base data types in this column here, you can see normally we'd put in one of the data types that you're familiar with, like a bool or an L real, or it might be integer or unsigned integer. But here we see this funny looking data type. If you're not familiar with these, this is an enumeration, which means it's a data type that has some pre-selected values that can go into it. We'll talk about enumerations in another video.